Hello everyone, we are today studying data mining basics. This is a part of DWM syllabus. So what data mining is? Data mining is hidden information that is present in the data but that is not easily visible to us. So data mining basically means to find patterns in data which are available in data but are not, as I said, not visible easily. So suppose there is an example and there is a Big Apple store. What Big Apple store is, it has about thousands of transactions per day. Like whenever we go to purchase anything, we buy something and there is a transaction. So what this is OLTP system, online transaction processing. The person at the counter of the Big Apple store, it performs the transaction, it inputs the data into the database, and that is OLTP. OLTP refers to what day-to-day operations that are performed for running the business. So OLTP is running the business. The operations required to run a business comes under the OLTP. Now these thousands and thousands of transactions are saved in a data warehouse. A data warehouse is a place where we clean these transactions and save them for analysis purposes. Uh, all these data has been saved in a data warehouse, and we want to perform analysis to find hidden information. We go to a store and buy brown bread, and we find that eggs are placed just across the brown bread because it has been found by the Walmart chain that it has done huge data mining that if a person is coming to buy brown bread and we offer him skim milk and eggs, then he will readily buy it also. So it leads to increase business. Is a diagram given here. This is a pile of data that is stored in a data warehouse. When we start data mining, we don't necessarily know that what we would be able to find. We can find very useful information, very useful patterns that how a buying transaction relates, how many products in it. Suppose this figure here given shows that we can find go very useful information that could help the business grow at a very good pace. So for the definition, we can say that data mining is a knowledge discovery process. Data mining helps you understand the substance of data in a special unsuspected way. It unearths patterns and trends in the world that you never knew existed. Means those things, those patterns which were there in the data, but you do not know that they are present. So data mining helps in finding patterns. There are two basic operations of a knowledge discovery process. One is relationships, finding the relationship, and the other one is finding pattern. Pattern discovery is another outcome of data mining along with relationships. Basically are the phases of a knowledge discovery. It starts with determination of business objectives, that what we want to achieve. Suppose for a chain like Big Apple, I just told you that determination of business objective would be to increase their sales. So if we have the objectives in the mind, then we can follow on the process. Next is selection and preparation of data. Now this process is very important, and you can see 45% of the total effort goes into this process. What this process is, gathering all these transactions in a place and then transforming this information to a different kind so that it could be easily used for data mining purposes. Okay, so it involves that removing waste data like what's the person name or what's the serial number and all, and just combining. I'm just giving an example. They're just combining only those information like which product have been bought. So it all depends on what the business objectives are, and that would depend upon the which type of data we choose. Next is application of data mining techniques. That which technique we will come across the various techniques further in the lecture. So there are many techniques and we can apply one of them. And then evaluation of the results. These four are the basic stages of our knowledge discovery process. Now this last phase of the result evaluation has actually two parts. One is evaluating results and presenting the discoveries. These go hand in hand. we find a one pattern, but we think that some changes to that pattern could result a better outcome. So this the discovery, presentation, and evaluation of these processes are really combined, actually combined in the last step. And last step is incorporated the use of discoveries. This means that what just implementing those, that keeping a few products side by side so that the sales could be increased. Okay. OLAP versus data mining. OLAP is online analytical processing. OLAP, as you some of know, maybe know this, OLAP is online analytical processing. It involves analyzing the data which has already occurred. Means that in the last 2 years, which customer defaulted on their mortgages. So online analytical processing involves querying the database for results that are already present in the database. Suppose which customer defaulted, you can easily the SQL queries and find what the customer by using certain parameters. But data mining is completely different. Data mining is predicting the future. It involves that which customers are likely to be bad credit risk. Suppose we have the database of 1,000 users, and some of them use credit card, and most and a section between them in those customers, there and certain customer always default on their payment. So the data mining system, what it would do is find those section of customer that are more likely to default on their payment. So we could identify them, and we could lower our risk. Another example, last year which store exceeded the prior sale. So what OLAP is basically is querying the database to get the results of certain queries that we know we can get the answer by changing the parameters. But data mining is different. It doesn't involve querying a database. It involves finding between the data. Now there is a very good differences table given on this page in the 437. You can look at that. What's the motivation for OLAP? OLAP is what is happening in the enterprise. What is actually happened is we can find through OLAP. But in data mining, we predict the future. Okay. Data granularity. Granularity is this level of details that are present in the database. OLAP requires only summary of data, but data mining requires a transaction level detail. Every detail, how much granular would depend how good quality data mining can be done. Okay, number of business dimensions is in OLAP it is limited, but in data mining it's very large. So this is a basic difference table that is given on this page 437. Now the relation between the data mining and data warehouse. As I earlier also told you, data warehouse is a place where we keep all the information, all the transaction history at a central place so that it could be used for analytical purposes. Data warehouse is used by two purposes, by OLAP and by data mining. OLAP is what I told you, that to know which information has is already stored in the and is already occurred for the business. But data mining is predicting. So data mining algorithms need large and large amount of data, more at the detailed level. Most data warehouse contain data at the lowest level of granularity. So how that would depend how better data mining we can achieve. Okay. This is the difference in the way data from the data warehouse is used for traditional analysis and data mining. When an analyst wants to perform an analysis, say they with an OLAP tool, with a summary or a high level data, then continues through the lower levels and build down. So it starts with the summary and going into detail, it gets what it wants. But data mining is different. as a data mining algorithm is searching for trends and patterns in a detailed data. So it's more of a bottom-up approach as is OLAP. Example of data warehouse being used by data mining system. This is all the part of the data warehouse to store the data, to create the data warehouse. These are all the previous stages, and how good the data warehouse is, we can perform the OLAP as well as data mining. Now coming to the main part of the chapter, major data mining techniques. What are the major techniques we can, the application areas are fraud detection, risk assessment, market. Suppose there is a credit card company. It analyzes users buying patterns for the last say 6 months or 1 year, and then applying algorithms of data mining, it can induce which customers are more likely to default on their payment. So we can identify those customers early at early stage, and we can limit their buying limit. Means how much they can spend, we can limit it. So it would lead to less loss for the company. This is one example. Another is risk assessment. Suppose there is a credit card company. Let's again take this example only. And some people, they had bad payment habits, but now they have, uh, likely to pay at time, so they can be upgraded. So there are various categories of customers which can be used to group them, that this customer is a better customer and this is a lower customer, to give them ratings. Comes under risk assessment. Another is market analysis, which I earlier also told you, that if brown bread is kept with skim milk, then both could be bought simultaneously, as people going to buy brown bread may also want skim milk with them. So okay, these are the major application areas of data mining. One is now coming to our application of cluster detection. Groups. Okay, clustering means identifying, forming groups. Okay. Clustering or cluster detection is one of the earliest data mining techniques. Means it has been used from a very past. Okay, this technique is used to designate as undirected knowledge discovery or unsupervised learning. There are two types of learning. One is supervised and one is unsupervised. Unsupervised means to form groups to find a yes or no kind of an answer. So clustering is an unsupervised learning technique. Okay, but this is one application of, it's just elaborated. There is one k-means algo. What it means is let us say you want to market the customers and are prepared to run marketing campaign for 15 different groups. Could be 15 here. Now what we want is, we want to divide our market into some groups so that we can run a marketing campaign. Suppose we want to run a campaign for youngsters in the age group of 18 to 25. We want a different campaign for 25 to 30 age group, and so on. So we have this 15, and we will use k as 15 here. We have 15 records for each, and 50 variables are chosen from the customer record. Suppose first name, last name, is buying pattern, and so on. There are 50 variables across which the person could be grouped. So what we do in k-means is, we plot them on a map and find some centroids, 15 centroids. They are actually given 4 only. So what we do is, we find a centroid for each group manually. There is no much logic behind it. Through intuition we find this, and we run this algo. What it does is, it groups similar kind of people into a single group. Okay, so this would be one centroid, this would be one centroid, this would be one centroid, this would be one centroid. After one cycle, it again finds the centroid of all these in one single group. So the centroid would change a little. Okay, and many iterations would be done, and after that we can find our group suite that we wanted to create. Now this very well explains what I was telling you, that this was the first step. These were the boundaries. In the second step, some were, better centroid position was taking place, and after a few iterations, we can finally create the centroid group. So we can use this to market our campaigns that for a certain age group, this campaign would result in the best results. Okay, things like that. Now there is another technique which is decision trees. What decision trees means is it applies to classification and prediction. Suppose we are going to buy a laptop. And tree means is we can start from a top level, and according to the properties we can move towards the answer. Suppose we want a light weight laptop and a medium weight. So depending upon our preferences, we can move to that part of our tree. So decision tree approach and answering in various that we want, the values that we want, and coming to the category. Suppose this is a W woman. Okay, so woman would like a comfortable laptop which has a keyboard. Okay, and storage is 10 GB or less. That would mean okay. And if the cost is more too, then also it would be preferred. And depending upon the the characteristics, we can group which people would like which product. This is decision table based. Another one is memory based reasoning. Okay, suppose you want to go to experienced doctor or novice, answer would be of course an experienced one. So memory based reasoning is nothing but uh, the experiences that something clicked at the last time, that some experience was used to answer a basic set of questions, then in the we can also apply the same basic principle. Memory based reasoning uses instances of a model to predict unknown instances. Suppose a similar kind of incident occurred in the history, okay, and some set of principles were used to solve it. Now memory based reasoning is finding the similarity between the current problem and the previous problem and applying those results that were used to solve the previous problem for the current problem. Okay, the algorithm knows the characteristics of records in the training data set. When a new record arrives for evaluation, the algorithm finds the neighbors and then uses the characteristics of the neighbors to find the predict and classify. So what was done for the previous in the training data set, what was done in history, and finding the similarity, we can apply this to find the solution for the current problem. Okay, this is memory based reasoning. Example of memory based reasoning. Okay, this is a very simple example. So the steps are also given. Selecting the most suitable historical records from the in the history, we find the best data set that is similar, most similar to it. Okay, establishing the best way to compose the historical record and determining the two essential functions, namely the distance function and the combination function, to find the problem solution to the current problem. Okay, another one is links to find relationship. Okay, link analysis. We are always we are all are connected through phone calls, connect people and establish relationships. Airlines link cities together. Okay, we everywhere are linked. So link analysis done is it has three actually applications. One is association discovery. Associations are affinities between the items. Okay, means finding the combination where presence of one item suggests the presence of another. Suppose in this example of the big apple chain that I told you in the lecture at the start, that if suppose skim milk is there, then it highly recommends that brown bread also is there. Nothing but finding the combination where two items would be together. Okay, sequential pattern discovery is a little bit different from it, is that if one thing occur, then it predicts that a certain set also occur. Okay, discover patterns where follows another specific set. Here time plays an important role. Okay, this is a sequential path. Suppose A event happens and in the historical data set A is followed by B, then C. So okay, it has we must have date and time as data items to enable discovery of sequential patterns. Okay. Uh, Now the third technique is similar time sequence discovery. This technique depends on the availability of time sequences. Similar is the case with the previous one. In the previous result, the difference was result indicated the sequential events over time. This technique, however, finds a sequence of events. So A occurred, then B occurred, then C occurred. Okay, and if this was in the historical, okay, then similar sequence of events that will occur in this example too. Okay, in retail department store, the example techniques comes up with a second department that has a sale similar to the first. Finding similar sequential price movements of stock is another application of this. Now coming to the next thing is neural networks. Neural networks mimic the human brain by learning from training dataset and applying the learning to and prediction. Okay, when the data is shapeless, then neural networks are very important. What they've done is that there are available and we have nodes which are the events. Okay, now some events lead to another, they give an input and those give another input and so on till discovery of the valuable information. Okay, this is a very deep technique but it's given very in a small, so it's just that. Now there are genetic algorithms, they are similar to neural networks but we have a weight assigned to every path. One group is say aged 35 and has $75,000 and we apply weight to them. Okay, and different weights can be applied that could result in different discoveries of data. So if the value is above a threshold, then we upgrade to gold credit card. So it's like finding patterns only. It's genetic algorithms. Okay, this is another example given. Suppose genetic algorithm has a different principle of survival of the fittest. Suppose there is a meeting going on to decide upon the coupons, how many coupons should be given to a certain user. So in a first attempt, 4 users give these gives one value. Then what we do is the best and the worst. Survival of the fittest means the average values survive better. Suppose one say 1500 coupons we should give, but that is a very more value. That is very huge value. That won't survive. But if we open 3 coupons per month, that also is very less. Okay, so the 13 and 36 value survives. In the second generation, we have 16 and 11, the average, which is 13 of it, and we have 36. We have 39 and 31. So these 31 and 39, if in a month, that is more than one per day in some days. Okay, so 16 and 11 looks better. And post in the third generation, we have 13, 19. So we can use any of the given values. This is genetic algorithm approach. Okay. Data mining techniques, as I already said that if a huge volume of data is available, then we can find the best patterns. Okay, also the quality of data depends upon how much detailing the data is available, how much detailed data is available. So as long as more data is detailed, that many attributes of data is given, then that refers to high quality data and that could perform a very good data mining application. Okay, very good differences table given that I just explained you in the previous just few moments. It shows how to compare various data mining tools. What are the properties that should be used for differentiating between them? First is data access. How much easier the access is. Okay, how much easily we can extract the data from the data warehouse. This is data access property. Data selection. a variety of data, not just for a very specific set. So data selection means the tool must be able to perform its operation according to a variety of criteria or limited criteria. Sensitivity to data quality. Okay, data quality is worth mentioning again. It has written the data mining tool must be data it mines. The tool must be able to recognize missing or incomplete data to compensate for it, so that we can achieve high visualization. Means process substantial data volumes and produce a wide range of results. Okay, if we have huge data available, then we should be able to visualize it. That is the property of a very. Okay, these are some other performance, performance. The tool must provide consistent performance irrespective of amount of data to be mined. It should be. It means it should. Or if say GBs of gigabytes of information is available, then its performance should not be degraded. The value of data size increases, then accuracy should also be there. And there are some other factors. Applications of data mining. Customer segmentation, as I already told you, if we want to market our campaigns for various age groups, then we can use this customer segmentation technique. Okay, to run out different campaign for different users and apply our marketing techniques. Another one is market basket analysis. That was the skim milk and brown bread valley analysis. Risk management is insurance companies and credit card companies use this technique to find the risk who will default on their payment. Fraud detection. Credit card companies uses this to discover abnormal spending. So huge in a particular month, then it find that maybe the credit card of the user is lost and some other fraud is taking place through that another application. Then there's delinquency tracking. Loan companies use this technology to track customers who are likely to default, so who will not pay their loan back. Demand prediction is retail and other businesses use data mining to match demand and supply to forecast that how much product they should order. Okay, benefits of data mining is the company can get demand it would have in the future, how much it should produce more, that it covers the demand, and also how can. So these are various basic applications of data mining. The supermarket chains, I told you how to keep similar buying items together so that the okay insurance company can use for detecting fraudulent claims. Okay, these are some other data mining. This was all about data mining. Feel free to ask any queries.